Specialists from a renowned technical department, Digital Foundry, published a detailed analysis of the new technology, NVIDIA DLSS, with dynamic multi-frame generation. Journalists personally benchmarked the AI-based algorithms and shared their thoughts on the future of computer graphics. The main innovation was the system dynamic frame generation, which operates like an automatic transmission for the GPU. The technology is capable of dynamically creating additional frames between real ones to ensure maximum image smoothness and achieve the monitor's target refresh rate.
So this week, NVIDIA has started to move on to different territories to show its CES demos. They had a presentation in London showing all of the CES stuff that you've already seen, Oliver. I had the chance to see NVIDIA DLSS multi-frame generation for the first time. The demo I saw, I'm not sure it's the same one you saw, but it was basically from the Outer Worlds 2.
Yes.
And yeah, that's the one. 4K, basically a locked or close to it, 240 frames per second. Latency indicator on screen was kind of like 40-ish milliseconds, which is good, I would say. And here's the thing, right? I mean, frame generation, there's a lot of pushback against it, but similar to upscaling, sorry guys, it's coming. It's going to become a key part of GPU, the outputs of GPUs going forward in the next generation for reasons which we've talked about in the past, principally that the cost of making GPUs is going up, the cost of silicon is going up, and we're going to be increasingly more reliant on machine learning-based features to give you the quote-unquote, and I don't like to use the word performance boosts, I will say frame rate boosts. I still think that's probably the way forward there. But you're starting to see a coherent vision come together because you had like multi-frame generation, 240 frames per second in one corner, and then literally right next to it, G-Sync Pulsar, where you've got like, I've got to say, John, it's the first time I saw it, and you're right, it is a game changer in display technology.
Right.
And you're right, the concept of what a high frame rate looks like and how it presents is very, very different when you've got a decent display that isn't smearing detail. And I think we're going to have to start looking at what a GPU does more holistically compared to, and how it interacts with new display technologies. And then there's the whole concept of latency. Now, in the sponsor video I did with ASUS, we had this situation where it was like, okay, well, let's take a look at what NVIDIA Reflex is actually doing. And you're seeing that without Reflex, games are actually, quote unquote, laggy based on the idea that people seem to think that frame generation adds unacceptable lag to games. Actually, what's happening is that frame generation with Reflex is sitting at a midway point between games without Reflex and games running with Reflex. And I just want to bring up this visualization here of, I extended the test that I did for Cyberpunk 2077 within that video, and I included a Radeon card, the 9070 and the 9070 and 9070 XT. And we have this really weird situation here where on an average, the NVIDIA card, the 5070, is actually the weakest in terms of frame rate. It's about 38 frames per second average. And then you've got the 9070 and 9070 XT, even with ray tracing, actually running faster than the NVIDIA card. However, the latency is higher than the NVIDIA card running at a lower frame rate. So this whole concept, I think, of how GPUs is going to evolve and where we're heading, there's sort of like established relationships that we have in our mind, which is that the faster a game runs, the lower the latency, which is true to a certain extent. But I think when you look at results like this, it's kind of like there's more to it. There's actually a more holistic viewpoint of base performance, base latencies, what frame generation is doing, and there are differences between the vendors there, which are quite interesting. The concept that the 9070 XT has got a significant frame rate advantage. It's like 12 frames per second faster on average than the 5070, but actually has higher input lag. It's kind of mind-blowing. I should say that I also tested the AMD cards with anti-lag on the driver level. Makes no difference, which says to me that AMD actually has that anti-lag kind of enabled at the driver level already. But Oliver, you saw all of these demos the same as I did. What do you make of all of this? Because it's an interesting time for graphics.
It is an interesting time for graphics, and we're getting into an era where the experience on NVIDIA and now increasingly Intel is getting harder and harder to compare to the AMD experience, because you've got multi-frame generation, you've got all these great anti-lag technologies, you've got ray reconstruction, you've got obviously a class-leading upscaling solution as well with the ray reconstruction light model, aka DLSS 4.5. So, you do have AMD analogs in some of those areas, but in other areas, you don't have AMD analogs. And indeed, when you look at the experience on a high-end PC of playing a game like Outer Worlds 2, even though its performance level is not my favorite, and even though I'm sure in the NVIDIA demo, Rich, I'm sure your demo was the same, it was in the enclosed ship area and not in the open world. That's like a bit tricky, and it is funny because it's like, yes, obviously you're getting this really high performance level with dynamic MFG at 240 frames per second, or, I'm sure you could push it well above that even on a monitor that was capable of it. But just the idea that you're getting that experience in a segment that's not very relevant to the gameplay experience, and if you actually get out the open world,
right? Yep.
Never mind even, shader compilation stutter. Obviously the game has significant issues with traversal on PC. But beyond the kind of like, let's say, PC hygiene issues of those titles and their various issues with traversal stutter and similar issues, that experience on PC with the super high frame rates, now with NVIDIA Pulsar, with ray reconstruction, with all this stuff, is just like pushing a level beyond what other vendors can supply. And it's really just a matter at this point of us kind of waiting and seeing whether AMD can kind of come close to some of these technologies. I think we're seeing with Intel that Intel is actually closer in some respects, or at least chasing these things a little bit closer to NVIDIA than AMD is. So I'm hoping that we see a little more homogenization from the graphics vendors, especially as we begin to approach the next generation of console hardware, in whether that's in 2020, 2027 or 2028. I want to see a more fulsome NVIDIA matching feature set than what's currently contemplated by AMD's offerings with Project Redstone. It's just not sufficient at the moment.
Right. Yeah, I think there is going to be a convergence of features, simply because it's the direction of travel. It's really interesting from my perspective that back in the day, the reason that you could produce perfectly fine like-for-like benchmark reviews of an AMD and an NVIDIA GPU was basically Microsoft was setting the standards with DirectX.
Mm-hmm.
Microsoft's not really done anything with DirectX since DirectX 12 Ultimate. And in the meantime, there's been a vacuum when NVIDIA has taken point with all of these machine learning-based technologies, which has created this disparity. And it's now to the point where Microsoft, in terms of DirectX, is almost irrelevant to the conversation, which has created this sort of situation. But John, I've got to talk about Pulsar, because you made a remarkable statement when we talked about Pulsar, which I didn't believe at the time until I saw it with my own eyes. Well, I wouldn't say I wouldn't believe it, because I trust what you say, but it was basically the concept that the perception of frame rate, the concept of having like 4x motion clarity does actually have an impact on how you perceive frame rate. And so the demo that we saw, I think it was the Anno game, and it was running at like 120 frames per second on Pulsar. But the motion clarity of it was just astonishingly good.
Yeah, absolutely. So, I mean, the reason this made sense to me is like, you go back and, play a game on a CRT, which I do all the time, right? And we always thought 60 FPS looks great, and it still does, right? But you put that 60 FPS on a flat panel, a high persistence display with sample and hold, it doesn't look so good, does it? It's very blurry. It really is. And it just never looked quite right as a result. And so naturally, when you get a low persistence display like a Pulsar monitor, essentially it solves that problem completely. And those lower frame rates suddenly look great. And that's really, really interesting stuff. And obviously the benefit of Pulsar is that you're able to do it with VRR. So you don't have to set a maximum limit to your frame rate, right? You can just enjoy it at whatever your GPU can pump out, but you get that perfect motion clarity all the time. And by the way, I do have a note from NVIDIA that they are still implementing the lower refresh rate option in firmware. It turned out to be more challenging than expected, apparently, but they are very much still hard at work on that, and hopefully we should have that fairly soon. So
Mm-hmm. Yeah, I'm looking forward to that. Just the more utility that screen has, the better, basically. I just want to quickly go back to that latency test because, I'm not going to be, I think we need to be quite clear about what I'm saying here about latency and frame rate. Obviously, if you look holistically at the result here, the 9070 XT has the highest frame rate and it has latency that's only slightly lower than the NVIDIA card. So, on balance with these particular settings, the 9070 XT is quote unquote the best. But what I'm trying to say is that the concept of what goes into a good experience provided by your graphics card is actually a bit more nuanced than just frame rate or just latency. It's going to be like a more holistic view of, I think, going forward, things, latency is important. The base frame rate, base latency is important. The frame generated latency, also important. And probably most crucially of all, the quality of those generated frames. So, it's pretty good at the moment. I think you'd agree, Oliver. But, when you are talking about 240 frames per second, what it does mean is that each frame is like persisting for like 4 milliseconds, I think. So it's, there's quite a lot of leeway in the quality of the generated frames there. I think, hopefully that's going to get better. You'd expect these technologies all to evolve as we move into the next generation. Looking forward to seeing what dynamic frame generation is going to look like, and certainly on more challenging fare. But again, going back to that latency test, I mean, I had to get sort of meaningful metrics here. I had to basically lock to native 1440p resolution, which you probably wouldn't be doing in the real world. On the NVIDIA side, you can get similar performance by using path tracing with DLSS, which you probably wouldn't be doing on the AMD side. It's really difficult to produce like-for-like metrics at this point based on how people are actually going to be using the cards. It's sort of moving into uncharted territory, and this is sort of, as I said, the direction of travel. But certainly a really interesting showcase of demos there, and dynamic frame generation. Yeah, I mean, 240 frames per second, 6F MFG, base frame rate would be like 40 frames per second, I guess. How good is that actually going to be? I guess we just have to find out.
In their article, the experts frankly stated that the constant rise in silicon and chip production costs will inevitably force the industry to rely on software-based methods to improve performance. The future of gaming hardware from NVIDIA and AMD is now directly linked to the development of neural networks and scaling algorithms, as increasing raw hardware power is becoming too expensive. The new version of the frame generator clearly demonstrates this transitional stage, offering intelligent resource allocation. If a game scene becomes too complex, the algorithm increases the number of generated frames to maintain smoothness, while in simpler scenes it reduces neural network intervention. The review paid special attention to the issue of input lag, which has always been a concern for competitive gamers. Thanks to the dynamic nature of the new technology, the lag level constantly changes depending on the current frame multiplier, allowing for more responsive controls when the graphics card is running low on resources. Journalists also praised the performance of the new displays with support for G-Sync Pulsar, which significantly improve the clarity of objects in motion and make the gaming experience as comfortable as possible even when using frame generation.